Okay, it says a car of mass 1400 kilograms moves on a horizontal straight road. So here's a straight horizontal road and a car of mass 1400 kilograms moves on it. Okay, let's say that the car moves in this direction. The resistance to the car's motion is constant and equal to 800 newtons. So if the car is moving in this direction, the resistance to the motion will be in the opposite direction, that is in this direction. Let's say that the resistance to motion is R newtons. Okay. The power of the car's engine is always constant and equal to P watts. So along its journey at each point, its power is what? It's P watts. So at a certain point in its journey, at an instant, when the car's speed is 18 meters per second and its acceleration is 0.5 meters per second, the first question is find the value of P. So at a certain point of its journey, its speed is 18 meters per second and its acceleration is equal to 0.5 meters per second squared. Now the first question is find the value of P. So how do we calculate P? Now whenever we have to calculate power, there are two formulae that we have to use in our syllabus. These are equals work done by time taken. In this case, both the work done and time taken are unknown, so this formula cannot be used. The other formula is power equals force times velocity. Okay, force times speed, and the speed is given. So if we can calculate the force, which we can from the given conditions, we can find the power. So let's find the force first of all. I forgot to mention one thing. The resistance to motion is constant and equal to 800 newtons. So this resistive force is equal to 800 newtons. So now we need the force. Now which force are we talking about? We are talking about the force generated by the car's engine. Which is this force. So we need this force. So how do we do this? Now if we resolve vertically in this direction, because the car is moving on a straight horizontal road, we have to use Newton's second law of motion, that is the net force is equal to ma. That's the resultant force. So what is the resultant force? Resultant force, as you can see, the car is moving in this direction, so the force F moves it in this direction. This is the force F, but the resistance to the motion is in this direction. So if we consider this as positive, this is gonna be negative. This is positive, this is going to be negative. But since the car moves in this direction and there is also a force, okay, force is acting in this direction as well, force is acting in this direction as well, but since the car is moving in this direction, this F force must be greater than 800 newtons. So the resultant force is F minus 800, and the resultant force is equal to ma. So what's the mass of the car? 1400. What's the acceleration? 0.5. Okay, if we calculate this, the force is going to be the 700 plus 800, 1500 newtons. So now the first question for 3 marks, that is power is equal to force times velocity, the force provided by the engine, that is 1500 times the velocity is 18. This is equal to 27,000 watts or 27 kilowatts. Okay, the car continues and passes through another point with speed 25 meters per second. So as the car moves on at another point, let's say as the mass is always the same. Along all points of its journey, the resistance to the motion and the power is constant, the question says. So the car continues and passes to another point. So at another point, as it moves on, the speed becomes 25 meters per second. And the question says, find the acceleration at this point for 2 marks. Okay, so how do we do this? Okay, that was question number 1. Now this is question number 2. Find the acceleration. Now the question says power is constant. Yeah, we have the velocity 25. So just look at this. F equals ma. The net force is F, which we can calculate. We have the mass and we need acceleration. So if we know the driving force at this point, we can calculate the acceleration. So we need the driving force. And how do we calculate this? We can calculate this by using power equals force times velocity. So power is constant, and that is equal to, let's see, 27,000 watts. The velocity is 25, so 27,000 divided by 25 will get the driving force. And from the driving force and this resistive force, we can calculate the net force, and if we divide that by the mass, we'll get the acceleration. So let's write this down. So first of all, the force is going to be, what's going to be? Power divided by velocity. Now remember that the force which we obtain from this is the force provided by the engine. That is to say, at this point, when the velocity is 25 meters per second, the force which we get from this equation is this force, the driving force, and this is equal to 27,000 divided by 25, which is 1080 newtons. Okay, so this is the driving force, 1080 newtons. So now we have the force. Again, the resistance to the motion is always constant and equal to 800 newtons. So therefore, what's the net force? The net force is going to be, resolving, the net force is going to be this force minus 800s, because force is acting in this direction as well and in this direction as well, but the car moves in this direction, so the driving force is greater than this force. Now this is equal to ma. What's the mass? 1400 times a. So a is equal to 280 divided by, I think, 1400, that is 0.2 meters per second. So this is how we do this. When power is involved, you may have to use this formula or this formula, but in most cases, so that we can use Newton's second law of motion to find acceleration and other forces, this formula, the questions involving this formula will be probably asked more, and this is how we do this. Just look at what are given, and yeah, this is how we do this. Just remember, net force equals ma. And thank you. I hope this is helpful.